Hey everybody, we are in all things algebra, but this is the geometry part 4-3 isosceles and equilateral triangles. I just finished part 1, which is problems 1 through 7. So I'm going to turn the page and pick up where I left off with number 8. Okay, let's see what we got here. All right, so I'm going to have to not only find x, which is what I had to do in the last 4 problems, but I'm going to have to plug in to find r, s, and t. Okay, well, I'll tell you right now. If you're a teacher and you're trying to wrap your mind around what you're teaching this year, because maybe you're brand new or whatever, you've never taught geometry before, or if you're a student who is completely lost, you're going to have to draw yourself a figure if you are a visual person. So I know I got a triangle, and it says that RT and ST are congruent to each other. See how they repeat the T? That makes T the vertex. So T will be at the top. The R and the S will be the ones that are equal to each other. So angle R and angle S are on the base. Now, how does that help me? Well, as a visual person, if you just got through watching my video, then you know that angle R and angle S are the two you set equal to each other. So if you're wondering, well, what does that do for me? It tells you what to do with the expressions they give you in the directions. These are my base angles. Those are the two that I set equal to each other. This angle T is my vertex angle. Now, if you want to add all three and set it equal to 180, you go right ahead. But the shortcut, because I'm a shortcut kind of girl, is that because R and S are on the base, those are equal to each other. Okay, so I am going to set 9x plus 2 equal, that leave myself enough room, equal to 13x minus 18. I'm going to solve for x, and I'm going to plug in to r, s, and t. Okay, here goes. I'm going to move my small x first. I'm going to add the 18. 4 times 5 is 20, so it looks like x is 5. But I am not done. In geometry, you do really want to make sure that you are answering the question fully. This one just happens to make it quite clear what you're going to do next. I got to find angle R. I got to find angle S. I got to find angle T. And I'm just going to use my calculator to do that. So I'm going to put 9 times 5 plus 2. 9 times 5 plus 2. So it looks like angle R is 47. Now, unless I've made a silly mistake, because angle R is 47, angle S should also be 47. Okay, 47. Now, unless I've made a mistake, I can do 180 minus 47 to get angle T. But I'm going to plug it in just to make sure that I haven't done, something silly. Because I have before. I'm going to check and make sure they add up to be 180. And they do. So I'm good to go. So listen, just because, I'm a teacher, I've been a geometry teacher for a very long time. I'm on year number 29. It doesn't make that I cannot make a silly mistake. I can. And if you're a teacher, own that mistake, okay? Don't ever say, oh, I just do that to make sure, y'all are paying attention. Yeah, okay. Kids aren't dumb. All right, here we go. Number 9, I've got a triangle DEF. All right, it says angle D and angle E are the ones that are congruent to each other. Well, just like I drew on number 8, I'm going to do the same thing here. If angle D and angle E are the ones that are equal to each other, that's your base. D and E are the ones that are equal to each other, which means F is the vertex. Now, if you're sitting there going, now how is that supposed to help me? Well, it tells me that FD and FE are my legs. FD and FE are the two that are equal to each other. So if you're a visual person, don't hesitate to give yourself something to draw. I mean, in all honesty, how are you supposed to know? Just by looking at the directions sometimes. So draw it out. That right there is only there to help you get this answer. So I'm going to put my 4x minus 8 leg equal to the 7x minus 35 leg. On an isosceles triangle, your legs are equal. Subtract the small x, or add, whatever you had to do. This one is to subtract. I want to add the number that does not have an x. What's that, 27? And then divide by 3. 9 times 3 is 27. So the answer is 9. For the x anyway. All right, this is geometry. I have to plug back in. So I'm going to take this 9 and I'm going to plug it back into DE, EF, and DF. Now remember, these should come out to be the same number because on an isosceles triangle, the legs are equal. DE should be different because that's your base. Now, if they all three come out to be the same thing, it's not really isosceles. It would then be equilateral. 9 plus 4, 13. Okay, I'm right here. 4 times 9, minus 8. Now, if I've done this right, DF should also be 28. 7 times 9, minus 35. Now, I cannot add these together to be 180. These are not angles. These are sides. So don't think that, oh, I need to add those to make up 180. Sides don't work that way. As a teacher, you're going to have some students that will try that and be like, well, why didn't it add up to be 180? Well, they're not angles. Those are sides of the triangle. Number 10. All right, we got another triangle here. Okay, it says that WX is congruent to WY. Remember, the one that repeats is the vertex. The X and the Y will be down at the base. That means that angle X and angle Y are the ones that are equal to each other. So angle X and angle Y, the base angles are equal. W is the vertex because that's the letter that repeated. WX, WY are equal. So if you're looking for a little trick, that's my trick that I show students all the time when I'm teaching this. Let's do it. 5x minus 12 is 7x minus 48. I'm going to subtract my 5x because that's just my smaller x. Just saves me more work. I'm going to add the 48. What's 48 minus 12? 36. And then divide by 2. My brain just shut down. Isn't that 18? Yeah, 18. Sorry, y'all. Brain freeze moment. All right, so x is 18. Now I have to plug back in. Now, if I've done this correct, whatever I get for angle X and angle Y should be the same. And then I'm going to check by adding all three to make sure they add up to be 180 degrees. I can do that because these are angles. Okay, here it goes. X plus 6 is going to be 18 plus 6. I get 24 degrees. All right. 5 times 18 minus 12. I get 78. And then 7 times 18 minus 48. 78 degrees. So my two base angles are equal. I'm good to go there. I am going to add these three angles together to make sure the three angles of a triangle add up to be 180. And ba-boom, baby, I'm in business. All right, so that looks like finishes us for isosceles triangles. Remember, an isosceles triangle has two equal sides that are called the legs and two equal angles that are called the base angles. Now, equilateral triangles, best day ever when you teach this. This is so easy. Equilateral triangle, and when you have all three sides that are the exact same, and an equilateral triangle is when all three angles are the exact same. So that being said, if angle A is equal to angle B is equal to angle C, then I guess they're all congruent. Is that what they want? I don't know. I would say, look, they're all 60 degrees. So maybe they want A is congruent to B is congruent to C. I don't know. They're all 60. 60, 60, 60. Okay. If AB is equal to BC and equal to AC, then I don't know. I guess they want that they're congruent. I don't know what they want. I'm going with that. BC congruent to AC. Now, I don't know what these measures are, okay? They could all be 2s. They could all be 5s. They could all be 25s. I don't know. I know they're congruent to each other, but until I have one, yeah, I don't know what the other ones are. All right. Like I said, God, isosceles are okay. Equilateral triangles, easy. All right, this is what I mean by this. This is an equilateral triangle. I know it because I have 2 angles that are 60 degrees, which means the third one is also 60, automatically. And if one side's 9, so are the other 2. Boom, done, easy. Number 12. Okay, it is marked equilateral. I know that because of these little marks right there. If one side is 24, they are all 24, and these angles are all 60. 60, 60, 60. Boom, boom, done. Ooh, now 13 looks interesting. That might be a little bit more difficult. All right, it says I got PQR. It's an equilateral triangle. Solve for X and solve for Y. Okay, no problem. No problem, no problem. Well, I see that this X right there is marked with a degree. It is angle R. Well, what are the degrees of the angles of every equilateral triangle? If you said 60, I'm loving you. Ba-da-ba-ba-ba. It's 60. Sorry, somebody walked in my door. All right. Well, I don't have any X to move, so let's start off by adding 3 to the other side. 60 and 3 makes 63. Oh, I had no idea. 7 times what? 63. Wait, I know. That's 9, isn't it? 7 times 9 is 63. Yeah. I was about to be dumb. All right, so there's X. X is 9. Okay, so it looks like I still have to find my Y. Now, I noticed that those don't have degree signs. These are sides. Now, listen. This is equilateral. So, I don't know. I'm going to pick 2 of them and set them equal to each other. It doesn't really matter which 2 I pick. I can pick these 2, set them equal to find Y. I can pick these 2, set it equal to find Y. I can pick these 2 equal to find Y. And we get the same answer regardless, so it doesn't really matter. Whatever. I'll go with 14Y minus 59. And I'll go with the 9Y plus 1. If you go with these 2, good for you. I mean, it doesn't really matter. They're equal to each other, so you can get the same answer. Whatever. Let's subtract the small y. All right. Got to get my pen to work first. All right, here we go. 14 minus 9. Bring down my minus 59. Bring down my 1. Add the 59. That's going to be 60. And that is a 12. 5 times 12 is 60. So y is 12, my lovely people. All right, x is 9 for bam. Y is 12 for bam. I'm done. All right, you guys. So this, again, was 4-3. Isosceles and equilateral triangles. If you have any questions, let me know. Ask your teacher. You know me. The practice problems are all y'all's. Good luck to you with the homework. See ya.